Hello again. So for this video, we'll be discussing still about circle theorems. This time with focus on tangents and secants of a circle. Okay, postulate on tangent line. So at a given point on a circle, one and only one line can be drawn that is tangent to the circle. So like what the theorem says, you can only draw one tangent line at every given point on a circle. So again, just take note, only one line, one tangent line for every point. Okay, let's have theorems on tangent line. The first one, if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Now let's use the figure here to explain the given theorem. So we have here line BF, okay? So we have line BF, and line BF is tangent to a circle I at point C. Okay, so point C is your point of tangency. Okay, now if we connect point C to the center of your circle, let's make a line connecting them. Okay, so we form, of course, this would be our radius, right? CI is a radius. So we form a radius that is perpendicular to the tangent line. So since they are perpendicular, meaning it will form a right angle. So we can say now that line BF is perpendicular to the radius CI. Okay. Okay, let's have the second one. So if a line is perpendicular to a radius of a circle at its endpoint that is on the circle, then the line is tangent to the circle. So if you notice, this one is just like the reverse of the first theorem. So we can say that this is the converse theorem of the previous one. So this time, you're given here is that you have a line. So let's use the same figure. So we have here a line, which is BF, okay? And we know that this line BF is perpendicular to a given radius, which is IC, right? And they intersect, okay? They intersect at the endpoint of the radius, which happens to be on the circle. When you have this one, your conclusion will be that the given line is a tangent line. Then BF is a tangent line. Okay, so just a reverse of the first one. Okay, let's have the third one. If two tangent segments are drawn to a circle from an external point, then, so two things will happen. The first one is that the two tangent segments are congruent. So let's use this figure below to explain the given theorem. So as you can see here, we have two tangent line here, okay? We'll just be using the segment, but we have here line AM and line PM, and both of them are tangent lines, okay? And they are drawn to circle from an external point, which is point M, okay? So if you have this kind of tangent tangent lines, okay, one result will be that the two given segments, okay, the part of the given tangent line will be equal. So here we will have AM, segment AM, be equal to segment PM. So AM is congruent to PM. Okay. Okay, let's continue. Let's have the second one. So again, from the previous one, let's recall that we will produce two congruent segments, right? So segment AM and segment PM. Now, let's read the second one. So the angles between the tangent segments and the line adjoining the external points to the center of the circles are congruent. So let's find out which angle are they talking about here. So we have here segment RM. This segment RM is the line that connects the external point to the center of the circle. So if you have this segment, these segments will divide, okay? Will divide the angle formed by the tangent segment. So here we will produce two congruent angles, and that would be angle AMR, okay? Wait first, okay? And angle RMP. And these two angles are also congruent. So let's write their names. So we will produce, for the second one, we will produce two congruent angles. This time it's angle AMR and angle PMR. Okay. Okay, let's have theorems on angles formed by tangents and secants. So the first one, if two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arc. So take a look at the given figure below, which is circle T. As you notice, we have two secant lines here, okay? We have lines RS and line LS. So both of them are secant lines. So these secant lines, they meet at an exterior point, point S, okay? Now, based on the given theorem, if you want to find the measure of the angle formed at the exterior of the circle, which is this one, let's mark it. Wait, okay. So that one, angle RSL, okay? All you need to do is get half the difference of the intercepted arcs. So which one here are the intercepted arcs? So these are your intercepted arcs. Let's mark it. Okay, so we have here RL, okay? So this is the first arc, and the other one is arc AH. Okay, now again, let's write a formula based from the given figure here, based from circle T. So we are looking for the measure of angle RSL. So again, based from the given theorem, it is half the difference, positive difference of the measure of the intercepted arc. So here that is the measure of RL, arc RL, minus the measure of arc AH. Okay. Now let's have an example applying this concept. Okay, let's have this one, find the value of x. So we have here circle T, and you have two secant lines here which intersect at an exterior point S. So we can follow the formula that we have just learned, okay, which is that the measure of RS, angle RSL. So let's write it again. So the measure of angle RSL is equal to the measure of arc RL minus the measure of arc AH divided by 2. Okay, so let's substitute the given information here. So we have the measure of angle RSL is 26 is equal to the measure of arc RL is 4x plus 21 minus the measure of arc AH, which is 3x plus 1, okay, divided by 2. Now we can cross multiply, so we will have 26 times 2, which is 52. And then let's simplify your numerator. So you will have 4x minus 3x, that is x, and 21 minus 1 is 20. Okay, solving for x, we have 52 minus 20, and that is 32. So we got the value of x. Okay, let's have the second one. So if a secant and a tangent intersect in the exterior of a circle, the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. So as you notice, the way of solving the measurement of the angle formed at the exterior of the circle is just the same with the previous one when you have two secants. Okay, so here let's write a formula. So we're looking for, based from the theorem, we can solve for the measure of angle RAS, okay, by getting half the positive difference between the intercepted arcs. So our intercepted arcs here are RS, okay, this one, and RP, okay. Just similar with the previous one. This time, we only have a tangent and a secant line, okay? But the process of solving it is similar. Okay, so we will have the measure of arc RS minus the measure of arc RP divided by 2, and that would be the measure of our angle RAS. So let's go straight solving for a problem applying this one. Okay, let's have this one. So let's solve for x and y. So as you can see, we have here secant RA and tangent TA. Okay, so we can use the formula that we have just learned. So let's apply that one. So the measure of angle RAT, so the measure of angle RAT is equal to half the measure of the difference of arc RT minus arc TM. Okay, divided by 2. Let's substitute the given values here. For angle RAT, we have 24. And then the measure of RT is 2x. And RTM is y all over 2. Okay, let's cross multiply. So this would be 24 times 2, which is 48. So as you can see, we have two variables here, x and y. So let's find a way where we can solve this equation, maybe cancel out one letter, so we can solve first with either x and y. So take a look back at the given figure. Let's find a way where we can write another equation, okay, to solve with the first equation that we have here. The 48 is equal to 2x minus y. Okay, so as you can see, um, a full circle has 360 degrees, right? So if we will add arc RM plus arc MT plus arc TR, we form a full circle. So that would be equal to 360 degrees. So let's do that one. Okay. So again, what we will do, we will add the measure of arc RM plus the measure of arc MT plus the measure of arc TR, and that should be equal to 360 degrees. You see that? Okay, so let's substitute the given values that we have. So for RM, that is 4x. MT is y. And TR is 2x. And that is equal to 360 degrees. Let's simplify 4x plus 2x. So that is 6x plus y is equal to 360 degrees. So we now have two equations here, two linear equation here, which is 6x plus y is equal to 360, and 48 is equal to 2x minus y. So we can solve it as a system, okay? We can either use substitution or elimination method. Excuse me. So we can just, how about let's do substitution, okay? So let's rewrite 6x plus y is equal to 360 solving for y. So if we do that one, this would be equal to y is equal to 360 minus 6x. Okay, and then we will substitute that to our first equation, which is 48 is equal to 2x plus y. So let's do that. Let's find a space. Okay, so our first equation is 48 is equal to 2x minus y. So we will substitute 360 minus 6x to the y of our first equation. So let's do that. 48 is equal to 2x. Let's change our y to 360 minus 6x. Okay, so let's simplify. So we will have 2x. Let's distribute the negative sign. So that would be minus 360 plus 6x. Okay, let's combine like terms. We will have 2x plus 6x, and that would be 8x. And then if we transpose 360 to the other side, you will have 48 plus 360, and that is 480. So we will have 480 is equal to 408, sorry. 408 is equal to 8x. Okay, dividing both sides by 8, we can solve for x, which is 51. Okay, so now we have the value of x. So solving for y, we can just substitute 51 to our y here, the second equation, the one that we have transformed. So let's do that one. So we will have y is equal to 360 minus 6 times, let's substitute 51 6 times 51. So this is 360 minus 6 times 51. That is 306. So subtracting it to 360, your y is equal to 54. So our x is 51 and our y is 54. Okay, so this time we have for two tangents. So if two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measure of the intercepted arc. So just the same as the two previous theorems, right? Only that the given here are tangent uh, segments, okay, or tangent lines. So to solve for the angle form at the exterior of the circle, here at the given figure here, that would be angle ORK. So let's go straight writing the formula because it's just the same as the two previous theorems anyway. So to find for the measure of angle ORK, so just get half the difference of the measure of the intercepted arcs here. It's OPK, okay? Arc OPK minus arc OK. Okay. Now let's apply this one. Okay. So we have here circle L and we need to find the measure of angle RST, this one. Okay, so we are given the measure of arc RT. So to solve for angle RST, we need to have the measure of the minor arc RT, the smaller one. Okay, so since a full circle is 360 degrees, to solve for the other arc, so just do 360 minus 248, and that would be 112. Okay, so now we can solve for the measure of angle RST, which is just subtract the two intercepted arcs. They are 248 minus 112 divided by 2. 248 minus 112, that is 136 divided by 2. So half of 136 is 68. So the measure of angle RST is 68. Okay, let's have the fourth one. This is second to the last. So if two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So take a look at the given figure here. So, this is circle E. Okay, we have two secants here, secants AD and BC, and they intersect at the interior of circle E. So when you have this one, so if you want to solve for the measure of the angles, okay, form at the interior of a circle, so what do we need to do? Get half the sum, okay, half the sum of the measure of the arcs intersected by the angle and its vertical angle. So if we are looking for the measure of angle 1, for example, okay, so we need to get half the sum of the measure of its intercepted arc. So the intercepted arc of angle 1 is arc AB, right? This one. So arc AB is the intercepted arc of angle 1. So let's put that one here. AB. Okay, and then we need to add the intercepted arc of its vertical angle. The vertical angle of angle 1 is angle 2. So the intercepted arc of angle 2 is arc CD. Okay, this one. Okay. Okay. So again, to solve for the measure of angle 1, just add the measure of the two intercepted arcs, okay, AB and CD, and then get half of it. So if you want to solve for the measure of angle 2, you have the same formula. So this is also equal to the measure of angle 2. Now, if you're solving for the measure of angle 3, so for example, measure of angle 3. So this time, the intercepted arc of angle 3 is arc BT. BD. So you need to add it up to the intercepted arc of its vertical angle, which is angle 4. Okay, and its intercepted arc is AC. So measure of arc AC divided by 2. So this is the same if you want to solve for the measure of angle 4. So let's go straight applying this one. Okay, so let's have this one, and we need to find the measure of arc AB. Okay, so we are looking for this one here. Okay, so as you can see, arc AB is the intercepted arc of angle ALB. So we are going to use the concept we just learned about secants meeting at the interior of a circle. So using the formula, so we can write the measure of angle ALB will be equal to the sum of the measure of arc AB, the one we are looking for, plus, okay, arc CD divided by 2. Now let us substitute the values that we have. So the measure of angle ALB is 106. Then the measure of arc AB, that's what we are looking for, so we just skip that. Plus the measure of arc CD is 155 divided by 2. Let's cross multiply. We will have 106 times 2. That is 212 is equal to the measure of arc AB plus 155. So let's just transpose 155 to the other side. So 212 minus 155 is 557. So the measure of arc AB is 57. So as simple as that. Okay, let's have the last one for now. Okay, so if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So this time we have a secant and a tangent, okay, but they don't intersect at the exterior. Instead, not also in the interior. Instead, they intersect at the point of tangency. So if you look at the given figure here, we have here secant PI and tangent TS. So they intersect at point I, okay? So if you have this one and you're looking for the measure of, for example, angle PIS, okay? This one. So based from the theorem, okay? So the measure to find the measure of this angle, just get half the measure of its intercepted arc. Now, what is the intercepted arc of angle PIS? Okay, so of course this is your intercepted arc. okay, which is arc PRI. Okay, so let's write a formula for that. So the measure of angle PIS is equal to 1/2 the measure of arc PRI. Okay, and if you want to find the other side, this one, angle PIT, for example, okay, that one. So find half the measure of its intercepted arc. Its intercepted arc is arc PI. So let's write that. So the measure of angle PIT is equal to 1/2 the measure of arc PI. Okay, so let's apply that. Okay, so let's have this one. This is the last example. So find the measure of arc PI. Okay, so looking at the given figure here, we have assigned x for the degree measure of arc PI. So if we want to solve for that, we need to have one method will be to find the measure of angle PIT, and then after that we can apply the previous theorem, the last theorem that we have learned. So since angle PIS form align with angle PIT, so we can just subtract 119 to 180. So if we do that one, we can find the measure of angle PIT, which is 61. So your angle PIT, so the measure of angle PIT here is 61. Now, based on the previous theorem that we have learned, the measure of your angle here is equal to 1/2 the measure of your intercepted arc, which is PI, arc PI. So measure of arc PI. Okay, which we also mark as x. So doing that, we will have x over 2. So we assign x for the measure of arc PI. So solving for x, so 61 times 2, that is 122. So therefore, x is equal to 102, and the measure of arc PI is 122. So, okay, so this would be the theorems related to tangent and secants. We have more theorems to learn for circles. So I hope you will watch the other videos that I'll be posting. Thank you for watching. Bye.